Hello and welcome back to the drawing board with me, Vicky. In this Christmas edition video, we will be talking about traffic loads in North Pole and how we can deviate from them depending on the project conditions. Our main character today is Santa. Santa has asked us to design a temporary bridge made out of candy, and it's going to be a 15-meter long bridge. This bridge will be used by his reindeer, so they will pull the sleigh on the packing point where the massive red bag full of presents will be loaded. When it comes to traffic loads, the first thing that comes on our mind is lorries and cars. However, this is not applicable in North Pole. It is more likely that the traffic loads will be the sleigh, the elves, the reindeers, Santa and the bag, rather than lorries or cars. So let's see each of them separately. A male reindeer, weighs about 180 kilograms, so they will give us a load of 1.8 kilonewton each. Although the entire Earth has been in lockdown since last year, Santa's life didn't really change at all. He was working from home all the year, and he didn't really feel the need to go out for a park run or get fit. So he managed to maintain his weight about 120 kilos, which is going to give us a load of 1.2 kilonewtons. Apart from Santa in North Pole lives these little hard-working creatures, the elves. Let's say that the elves in groups of 6 are having exactly the same weight as Santa, so they will give us a load of 1.2 kilonewtons. Usually the elves will use the bridge to visit Santa and resolve any problems with manufacturing the presents. Next on our list is the sleigh. Santa's sleigh is rustic on the outside, but a marvel of engineering on the inside. Santa keeps as a secret the material it is made of, but he has given us the weight, so it's going to be about 2 kilonewtons. Last and most critical is the bag. Although Santa has found a way to compress the presents and minimize their weight to nanograms, the population of the Earth is really a big number. So this is going to give us a really massive load, orders of magnitude bigger than any other traffic load. Just because of the purpose of this bridge, the bag is not going to be on the sleigh. So we're going to deduct this load entirely from our design. So I'll put all the loads in the bridge. So I've got my reindeer, all 4 of them actually here. We will assume that they are about half a meter apart. And just for our calculations, to make this number very round, I will put the elves exactly where the reindeers are. This reindeer seems to be a bit naughty. So I'll put them all here. And I've got at the very end the sleigh and Santa. So the next step on our design procedure is to see what the maximum design effect on the bridge will be. I've got some loads here that are moving on the bridge. We usually use rolling load analysis, either spreadsheets or software. What they are doing, we have to input the vertical loads and the spacings between those loads. And what this software is doing, it starts the first load from the beginning of the bridge, and it calculates the bending effect, the design effect. Then it moves all the loads by a specific distance, run the same calculation again. And this is happening until the last load crosses the bridge. Then this software is going to give us the maximum bending moment, probably sometimes the location of the first or the last load. Now, before we present these results to Santa, we had a discussion with him. Speaking with him, I've explained him my deductions and that the results do not account for the breed self-weight, and all my loads for the time being are unfactored, just to have an idea. With my rolling load analysis, we found out that the maximum bending effect on the bridge is going to be 34 kilonewton meters. We had also a discussion about the recent second lockdown, and he was overwhelmed. He, of course, takes very seriously the health and safety of his workforce, so he decided to social distance the reindeers before and during the journey, the magic journey on Christmas Eve. Of course, he asked the elves not to visit him anymore. All their meetings were transferred digitally. So I'm going to take the elves off my breeds because they're not an active load anymore. And I will social distance our reindeers. So now they're going to be 4 meters apart. So the clearance between each reindeer is going to be 2 meters. Both Santa and the sleigh were naughty. So I'm going to put them somewhere here. So if we keep them on 4 meters spacings, 1, 2, 3, 4 spacings, 4 by 4, it's giving me 16 meters, and my bridge is 15. So one of my reindeers probably won't be on the bridge when I will have the maximum bending moment. From the rolling load analysis, which I have already run, it is going to be this kind of configuration that will give me the maximum design effects. And in terms of the bending moment, this is going to be 15 kilonewton meters. So we can see that by considering the new circumstances, the social distancing and COVID-free circumstances, the loads have completely changed, and the design effect have changed as well. As a result, we have a massive drop of more than 50%. Overall, when designing something, we have to consider of the loads, of the combinations, and we have to make the right decisions. Understanding the nature, the conditions of the project, and making reasonable assumptions can always lead to a more accurate, economical and sustainable design. I hope you enjoyed this Back to the Drawing Board. If you like this video, please subscribe, like or share. Here in Groundforce, we wish you all Merry Christmas and a Happy New Year.